Hey everyone, it's time for another exciting episode of Intro to R. So today we're going to talk about looping, which is probably my favorite computer science concept, we'll have to say, because it makes everything so much easier and so much faster. So let's get started and talk about looping. Okay, so looping. We're continuing on with this idea of flow control and computing, and it's just the idea of computers are good at really one thing, and that one thing is doing the same thing over and over again, but you don't want to tell it, if you have small changes to make, you don't want to tell it every time, well, just change this number to 1, change this number to 2, change this number to 3, change this number to 4. You really want to sort of set them off with some basic instructions and let them go. And so looping is this other main method of flow control besides just the super basic decision making based on conditions that helps computers run without intervention. Okay, so loops are sections of code that run repeatedly until a stop condition is met. And you'd find that stop condition. Yeah, and loops allow code to run while changing things automatically and running sections of code. So this is really, really useful if you have a lot of different calculations to do and you don't really want to tell it like, oh, now just change it to 1, now just change it to 2, et cetera, right? So taken together, functions, conditional statements, and loops make for a really powerful trifecta in computing. So we're actually going to mix all three of these together today. So if you haven't gotten a chance to watch this Code Academy video on loops, I want you to go ahead and click it, watch it, put this one on pause and watch this load. It's just a great little video explainer about loops. And I think it'll do a good job to help set the stage for what we're going to talk to. So go ahead and pause here if you haven't watched the video. It's 3 or 4 minutes long. It's not very long. So pause here, go watch the video, come back. Okay, I hope you're back. So for repeat loops, so the first type of loop we're going to talk about is just something that repeats. Repeat loops simply repeat a section of code. That's all they do. And they will continue to repeat until you break it. Okay, so in the in the notebook, you can play this comment and it just repeats. And you'll notice that there's no way to break it. So you actually have to stop this from running. And the way that you do that is Control C. So you can Control C, it'll stop this. But here's the basic structure of this. You'll notice this is one of the few functions that you actually don't have the parentheses here. It's repeat, and it's just giving the command, please repeat the following lines of code. And then this sort of purple is what you should repeat, telling the computer. If you want to put multiple lines, you can put multiple lines, and you just do that in curly braces so that it looks like this. So here's this. Again, it's just repeating, and it will continue to repeat until you kill it. So go ahead and kill it with Control C. And again, you may want to, if you're trying to knit this, please don't, because it won't work. But you can restart R and clear output so that it gets rid of all of that stuff. So you can go through the rest of the thing with us. So yeah, don't try to run these, because again, they literally won't stop because there's no break set. So they just keep going. Okay, so that is maybe possibly not the most helpful thing, you know? So stopping, let's learn how to stop repeat loops, because that makes it a little bit more useful. The break command will stop a repeat loop and any other type of loop that you have that you've set up. So if you run this next thing, it again will only let this loop run once, okay, because it prints the first line, the second line, and then it breaks the loop. So it only allows the run, which again, is not super helpful, but we're just figuring out how these things work. If you, the real way that you can do that is setting up a condition to meet before breaking. And this is a little bit more useful, right? So in this example, we're setting X initially to be 1, we're repeating the first line here is actually just going to add 1 to x and overwrite it. It's going to print, and then this final thing is an if statement. If x equals 10, then I want you to break. And so what this ends up looking like is this. Okay, so it repeats 10 times and then stops, which is good. So great. That's a repeat loop with a break. You can add a conditional again to decide how many times to break it, or how many times after which you should break it. But remember to set that condition and then be adding on to this x, because otherwise you get into an infinite loop as well, infinite repeat. So I want you to break now. And check your understanding. I want you to write a repeat loop that prints the value of the repetition and stops after 100 repetitions. Okay, so go ahead and pop into that notebook, check your understanding here, and write that out. That prints the number, the value of the repetition, and stops after 100 repetitions. Okay, hopefully you're back and maybe you struggled a little bit with that. It's a little bit weird to see. Get used to doing that sort of thing, but hopefully you're back. And again, if you have any questions, you can note that and ask it during class. Okay, let's talk about a different type of loop, and this is the while loop. So while loops look really similar to repeat loops, except they take that condition as a stopping as an argument. Okay, so this one's going to be really similar. We can use x as a counter to stop the loop when it reaches 11. And so again, we predefine what x is, just x equals 1. And then so the syntax here is while does take the parentheses arguments here, and then inside is going to be that condition for break. Okay, so what we're saying is while x is less than 11, I want you to run these lines. So you print, this will keep printing while x is less than 11. And then you're going to remember to add on to x for each of those loops, right? Because otherwise x will never get to be over 11, and then you'll just have an infinite loop again. It's really easy to do this, which is just why you have to remember to do control C to kill it. So this is what it ends up looking like. It just repeats this line 10 times, right? Because when it hits 11 at the top, it's going to stop the loop. It's going to break the loop before it runs at an 11th time, okay? All right, don't forget again to include a statement that turns false again. So whenever this is true, the while loop will continue to repeat those lines, and as soon as it turns false at the top, it's going to stop the repeat. Okay, so you're going to wait forever for that loop to stop if you don't make sure that this argument at some point that is appropriate turns false, right? Okay. So it's easy to substitute x for the value of x in any calculation. So you can, again, look at this, and we're printing this pasted situation here, which x is x, so the value of x out of 10, and then we add 1 to x. Okay, so what this ends up looking like is this. The value of x is 1 out of 10, 2 out of 10, 3 out of 10, blah, 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 blah. Okay, so right, that's really useful. Okay, so now that we've talked about while loops, we're going to hit on for loops, which is probably the most common type of loop that you see in computing. I mean, I see while all the time too, but mostly it's for loops that I'll see. For loops repeat for a predetermined number of times that you set as an argument. So instead of setting a stop condition, what you're going to say is, I want you to loop through this vector. Okay, so in each time you loop through it, you're going to take on the first number, then the second element, the third element, the fourth element, the fifth, so forth and so on to the end of the vector, and then I want you to stop. Okay. So it's pretty straightforward. Each time the loop starts, the value of the variable will change to the next value in that vector. These are a little bit easier. You don't get into this situation very often with for loops where you have an infinite loop, because your stop condition is just the length of that vector. And you can't make infinite length vectors in R. So it's a lot less hard. It's a lot easier to make a determinate and not an infinite loop, a finite loop. With these guys. So here's our for loop. Here's the syntax here. So the for command does take, again, the parentheses, and in that argument, you're going to do your variable. the word in, okay, which is an important component that, and then a vector. And here we've set a vector as sequence 1 to 10 for whole numbers. And then inside the curly braces, and again, you can put this, if you only have one line, you can actually just put it all on the same line and it'll execute just that line. But if you want more than one line, you put them inside curly braces. And then we're going to do the print paste x is the value of x out of 10. Okay, so this is essentially going to give you the same stuff. So the variable will run every number in a sequence 1 to 10. And in this example produces exactly the same output as the repeat and while loops here. So here it is. You run it here and it's the value of x is 1. So the first repetition, it takes on the value 1. The second repetition, it takes on the value of 2, 3, 4, so on all the way until 10, okay? Pretty straightforward. The vector itself doesn't need to be a sequence of whole numbers. You can do it by partials. So here we're creating a sequence 1 to 5 and stepping it forward by 0.1, okay? And so if we run this example here, we see that each time the value is within the sequence. So the first element is 1, 1.1, 1.2, 1.3, 1.4, so forth and so on until we hit 5, which is the end of this vector right here, the sequence vector, and then it stops. Okay, good. It also doesn't even need to be sequenced. Any vector will really do. Here in this example, I'm running actually x in just a random set of 10 numbers, and this will give you, the value of x is just the first position, the second position, third, fourth, so on and so forth. And you can see that here. Okay. So yeah, that's pretty straightforward for loops. You can also nest for loops, which is pretty fun. This next example nests one for loop inside another. So for the outer loop, we call it the outer loop because it's on the outside, right? We're setting the variable to x. X is going to cycle 1 through 5. And then the inner loop, we're going to set a variable y. So it's really important that you do set these variables to be different from each other, because if you set x in here, then it's probably going to get pretty confused. It's going to be pretty confusing as to what's going on. But y, this inner variable, is going to run 6 to 10. Okay, so what you end up getting here is the output like this, and you can run it in the notebook as well. Okay, and this you'll notice that even though this is only supposed to, this outer loop runs 5 times and this inner loop runs 5 times, what happens is it executes by line. Okay, so it executes by line. The first line, it's like, okay, x equals 1, and then you go, okay, y equals 6. It prints the value of x equals 1 and y is 6. And then what it doesn't do, it doesn't go back to the outer loop. It completes the inner loop, okay, before it moves on to the outer loop. So you get x is 1, y is 7, x is 1, y is 8, x is 1, y is 9, x is 1, y is 10. And then it switches, it's like, okay, done with this inner loop, time to go back to the outer loop. The outer loop, okay, now x is 2, and then it goes back in and does the inner loop completely over again. Okay, so you end up getting 25 outputs here. I've cut this off in the slide, but here's the full thing. You end up getting 25 outputs because it's the number of times the inner loop, the outer loop has to run times the number of loops, the inner repetitions the inner loop has to run. Okay, so again, the inner loop will do a full cycle for every repetition of that outer loop. Okay, and so here's this. All right, so we've talked about all 3 of the major types of loops. And one of the things that we want to go ahead and do is implicit looping with apply. Apply is a function that applies a function over the margins of a matrix, and the margins meaning like either rows, which is 1, and columns, which is 2. Okay, it's an implicit loop because it has the same output as an explicit loop, one that you like explicitly say for, like do this loop, but it doesn't use for, while, or repeat, okay, to do it. So if we set up this example matrix, what happens is we are creating a matrix that looks like this. There we go. Here's your matrix, example matrix, 3 rows and 5 columns. Now we want to compute first the column means. with a for loop first, just to show you how it goes. And this is what is going to happen is that this first thing is called pre-allocating space. So we're just creating a vector that is the same length as the number of columns. Okay, so it's going to basically set a bunch of little boxes open, little spaces for the answer to be dropped in each one of those boxes. And so there's going to be 5 column means, yeah, that's right. 5 column means, yep. And so five boxes, so 5 NAs here. And again, that's called pre-allocating space for answers because you just create a little box and drop those things in. The second thing you're going to do is set X, and the sequence is going to be 1 to the number of columns. Okay, so we're not saying, oh, I want to, how many columns are there? There are 5. What we want to do is actually, we want to just leave this flexible. So if this happens to change 3, this actually is 3 columns right here instead of 5. But my example in the Markdown document is 5 instead of 3. This is going to remain flexible. So it's going to base how many loops to do and how many of these to calculate based on how big my example is. And then it's going to repeat this number of times, the number of columns. The mean, it's going to take the mean of the column in that position. So 1, 2, 3, 4, 5, etc. And then it's going to store it in the corresponding box number, okay, in this this NA vector that we set up. And you can see as we do this that the 5 columns here for this example matrix is 2, 5, 8, 11, and 14, which again is just the mean ones because it's going up and down by 1, okay? So we can also compute this with apply, and it's much shorter, right? You just, you're going to create that column means 2, which is going to be the same as column means 1, should be the same as column means 1. You're just going to assign the output of apply onto that new object. The way that you would do apply is, again, just, whoops, the example matrix that you want to go over, the margin. So 1 is rows and 2 is columns. So here we're doing columns, and then the function name, which is going to be mean. Okay, don't bother putting the parentheses. It's doing a search name match there. Okay, and here we'll see that this is exactly the same. So yay, good. All right. So now that we know a little bit more about loops, I want to just discuss what good are. Why do people use loops? What's this good for? They're really, really useful, especially if you need to do repeated calculations. They're extremely fast. They're very useful, and they will step through any number of calculations that you want and tell it to. For an example that we have up here, excuse me. Remember, one of the homeworks asked you, the vectors homework actually, asked you to do a element-wise calculation of some vector and added 1.3 to it. And remember, the vectorized calculation that we could do for this is, so if we do vec1, we could just do vec1 plus 1.3, okay, and it adds 1.3 to each of these elements, but then I asked you to do it element-wise, which means adding 1.3 to each individual element of vec1. Okay, so here we're going to do vec2. We're going to again pre-allocate space for vec2 right there, and then we're going to use a for loop to loop over the elements in vec1, so 1 to the length, the end of vec1, and then we're going to use that to add to each element 1.3 and then store it in this vec2. And what we end up with 2 is the same answer as just doing this element-wise repeat, which is pretty cool. Okay, so performing the results. This is a really simple calculation. Obviously, this isn't very complicated. You could do this much quicker by doing an element-wise or by a vectorized calculation with R. However, you'll notice that when you're doing this in R, it's not that it's actually behaving the same way. But what you're doing is pushing this loop, this for loop down into C. So it's not like when you do this, it's not doing a for loop. It absolutely is. It's just doing it about down base, we call it pushing down into C. So all of the base code that R is written in, most of the base code is written in C. And so what it's doing is pushing that down. So essentially what you're doing is just calling a for loop when you do this type of add, okay? So when you do this type of add, you're actually calling a for loop. It's just pushing it down into C, which is a good bit faster, okay? So you know now how vectorized calculations are actually done in C. So when should you use loops, and which loops should you use? Because obviously we've talked about a bunch of them. Loops are great for repeating calculations. Again, if you have like 500 calculations, 1,000 calculations, a million that you need to do, you want to put that in a repeat loop or some kind of loop. All of these loops options are really similar. They can be coded mostly to produce the same output. Remember we did an example for repeat, while, and for that all produced exactly the same output. You just code it a little bit differently. So it essentially doesn't matter in most cases, okay? For loops are probably the most common because they're the easiest to understand, and they're also the easiest not to get into a situation where you produce an infinite loop. So it's a little bit easier to get into an infinite loop with obviously repeat because you don't set a break condition correctly, or while because for whatever reason the break condition never turns false. Okay, so for loops run on that predetermined number of times. But many people also use apply or similar functions to implicitly loop in R. And that is a little bit more restrictive because the data, and I've included a list of the different apply functions here. And they're a little bit more restrictive because again, like lapply only works over a list or a vector. Apply only works over a matrix, you know, so those end up being a little bit more restrictive, although those are very common data types that you may have in R. So, but if you can't figure it out how to use an apply command, one of these apply commands or functions, you can always just default to a for loop now that you know how to do it. So for the last check your understanding, I want you to actually calculate the Fibonacci sequence or series. And it's a series of numbers, if you're not familiar with it, in which each number in the series is defined by adding the two previous numbers. So the first two are 0 and 1, then 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, et cetera, and you can keep going on forever. But I want you to use a for loop that calculates the first 500 Fibonacci numbers, okay? So you can't do this by hand, it's gonna be too much. I've gotten you started though with the first few numbers here in the Fibonacci series, I think the first 4. So you have somewhere to start, which is great. You have an empty vector that you can fill here with numbers. Yeah, and so what you need to do is do a for loop or any sort of loop. It doesn't matter. It doesn't have to be a for loop, but write a loop that calculates the first 500 of those numbers and fills all these boxes in this fib.nums. All right. So with that, I think we're pretty much done. There's an assignment 3.4 that you'll need to do, and then you can read Davies chapter 10.3 for next time. But I am done for now, and I'd like you to keep on coding.